Good Monday to everybody in Gov 603. Welcome to week boom, bam, 13, or if you live in Europe, 13. Week 13. Hey, how are you holding up there? We got really 2 more weeks of classwork, and then it's final paper, final exam time. So I hope you're doing well, and stay turbocharged like I do. Hang on. Thank goodness for hot beverages. Okay, everybody, now I'm your sufficiently caffeinated instructor here for another week with you. And it's springtime. I don't know where it is where you live, but finally the temperatures are getting up there, which means for me, poor old me, things are in bloom, which means my allergies are in bloom. So if I'm a little sniffly throughout this video, I have a tissue or two, I beg your patience. All right, now, coming into week 13, you should be working on your papers, hard at work, and likewise preparing for the final exam. Again, I know, excuse me, I've said this before, but let me remind you again. How do you prepare for the final exam? Go back and look at Blackboard. 4 questions a week, reliably. Look at the major terms, the concepts. Okay. And be able to articulate them to yourself or to somebody else. Get together in a study group in plain, simple English. All right. So anything from Blackboard and anything from these videos is fair game for the final exam. Okay. If you have any questions, you have any concerns, reach out to me. Catch me during my office hours. I am here to help you. All right. Let's take a look at the questions and answers from week 12. This is, week 12, this is an important week because there are some fundamental concepts within this week that you need to understand. And you need to understand how it is that we derive the terms that we have, like categorical and continuous. I'll touch on that here in just a second. But also, in reading through your answers, I can tell that there are some people, and I'm not pointing any fingers, who are copying things from the internet, which in itself is not a bad thing because this isn't a paper really, so it's not so much a plagiarism issue, but it is rather I can see from reading the text, or I should say, I wonder from reading the text if you understand the concept, and if I asked you to explain the various aspects of the, say the question, like what's a dummy variable, the various elements to your answer that you roll out. Could you explain to me if I just pulled apart, took apart, not pulled apart, but took apart of one of your answers and said, okay, explain this to me. What does this mean? Could you do it? And if you can't, that's where you're going to get in trouble. All right. Not like for the discussion boards, but for what's coming on the final exam. So please, you've heard this from me before, but I am begging you, make sure you understand the concepts. And to demonstrate such and to help yourself, make sure you understand this. When you give your answers in Blackboard, give them in simple, plain English. Okay? I want you to break down the jargon. All right? Well, that being said, let's take a look at the questions. Question number 1, what is a dummy variable? How is it created? Why would a researcher use it? Either post an example in your research or link to an example online. Okay, Richard, you went first. I'll take you first. According to Tim Bach, I don't know this person, a dummy variable is a variable that has a value of 0 and 1. Okay, true. Now, immediately, I'm going to sort of zero in on what I was saying just a second ago. The dummy variable does not have a value of 0 or 1. It is assigned. It's given a value of either 0 or 1. Here, try to, now not you, Richard. We'll go back to your answer in a second. But for everybody, try to picture it like this. Keep this in mind when you're looking at research, okay? Data is out there. Data is just information. It's any information about anything. What is this rock made out of? That's data. What's in my coffee cup? That's what's left of my coffee. That's data. Okay. How severely am I afflicted by allergies? Based on how many antihistamines I take. That's data. It's all, data is all this information swimming around out here. Okay. We can call it and we can put it into different categories. So for instance, I'm going to jump ahead a couple of questions here from last week. We could describe information about what's happening out here using categorical data or using continuous data. All right. Same thing. You know, I'll give you an example in a little bit. We could discuss eye color as either continuous. We could set it up so we create continuous data, or we create categorical data. See, data is not a certain thing like say fruit, is not a vegetable. And within data, there are not set things like within fruit. There are apples and oranges. And oranges have certain characteristics and apples have certain characteristics. And you could take the two, hold them in your hand and say, hold the apple and say, this is an orange, and hold the orange and say, this is an apple. But that doesn't make the orange an apple. They are what they are, independent of any labels that we give to them. All right, they're set in their forms. Data is not like that. All right, we can put data into certain categories that we choose to put it in. All right, so, and you might sound like, whoa there, Dr. G, you seem like you're kind of wound up about this. No, not really, but it's really important that you understand that a dummy variable, and I'm going to go back to you, Richard, and I'm not picking on you, Richard, but I'm just using this as a jump-off point. A dummy variable is a variable that has a value of 0 and 1. No, we assign it 0 or 1, okay? And then we continue, where the value either indicates the presence or absence of something. Okay, well, that's true, and that's why we use, 0 and 1. But that's completely arbitrary. We could use 7 and 10 and say 10 means it has nothing. Okay, that's up to us. Whereas a placebo may indicate a 0, while an actual drug may indicate a 1. Now, I get what you're getting at there, but that's not the best of examples, because in the case of drug and placebo is a non-drug. It has no effect except for what's in your mind. Drug is a drug, and it has effect. Okay, but remember the video that I had you watch, where the person is driving down the road and or they're watching and they want to calculate what's the relationship between fuel efficiency, horsepower, and vehicle type. And they say all these vehicles go by and they're writing them down, and they notice that there are sports cars, two-door sedans, family buses, and pickup trucks. Okay, so they have to be able to decide how they're going to they want to do a regression analysis using categorical data, but regression analysis mathematically don't work, all right, with multiple categories. You have to reduce that down to one category or another. So you just say, okay, well, we're first going to ask the question about the relationship between fuel efficiency, horsepower, and trucks. So the first group of cars that we say, sports cars, are they trucks? Yes or no? No, they get assigned the value of 0. Second group of cars, what do we say? Two-door sedans, are they trucks? Yes or no? No, they get a number of 0. Third category of vehicles that we saw, we were standing there on the side of the road writing them, counting them. Third category of vehicles, family minivans, are they trucks? Yes or no? No, they get we're going to assign them a number 0. Fourth category of vehicle that we saw go by, trucks, are they trucks? Yes, we'll give them a number 1. Okay, so it's not that, like a placebo and a drug, where a placebo is nothing and a drug is something. It's just, it's not a member of the group. So sports cars, two-door sedans, and minivans are not trucks, but they're still vehicles. The group meaning truck. Does everybody understand this? Okay. And again, Richard, I'm not picking on you. I'm just using this as a good jumping off point. Okay. A categorical variable has more than two categorical variable has more than 2 categories, may have a set of dummy variables. Well, if we decide to create it, yes. Numeric values of variables may also have dummy variables that are coded to explore nonlinear effects. Okay, right there. This is what I'm talking about. Richard, now I am addressing you directly. If I asked you, could you explain this sentence? Numeric values or variables may also have dummy variables that are coded to explore nonlinear effects. What does that mean? Now, if you can answer that, great. You are way out on the tip of the spear where I'd love everybody to be. If you can't, then don't just copy language. Now, and this applies to everybody. This isn't just, this person that answered this. Don't just copy language and slap it into your answer. Okay? Dummy variables may also be called indicator variables, design variables, contrast, one-hot coding, binary basis variables. Dummy variables are primarily used as predictors in statistical and machine learning models of categorical variables. Okay, again, could you explain that? And if you can't, be sure that you can break it down, because wink, wink, you may, like say, you might get a question somewhere, final exam, that says, that'll give you either a fill in a blank or a short answer. All right. And it might run something like, in plain English, explain what a dummy variable is, how it's created, or, explain why, how, and what a dummy variable is, why it's created, how it's created, and why. And if your answer is a dummy variable could be called an indicator variable, well, no, that's like saying, an apple could be called Red Delicious or Gala, but that doesn't tell me what an apple is. That just gives me another name. Again, Richard, no one's picking on you here. I'm using this as an example. Okay, let's go a little further down the line. Judah, as described by Trochem, not quite sure how to pronounce the name, a dummy variable is, quote, a numerical variable used in regression analysis to represent subgroups of the sample in your study. All right, that's getting closer. All right, it's a number that you assign to represent a subgroup, like, say, trucks, within a group, vehicles, within your study. If a researcher has more than two subgroups or categories in their analysis, it's necessary to use a dummy variable to calculate. In the calculation, and you're citing a data tab, and that's the video that I gave you. Dummy variables are created by using binary category variables to represent categories in an regression analysis. If a piece of data is in a category, the variable has a value of 1. Otherwise, it has a value of 0, meaning if it's not in that category, it gets the value of 0. There is always one less dummy variable than the number of categories, because a piece of data with values of 0 in every category represents an additional category by implication. Meaning, and if you watch the data tab video, data lab, excuse me, it's a data tab. Or yeah, it is data tab video, and you'll see that when you create this table, in which it's the vehicles down the side here, sports car, what did we say? 2-door sedan, minivan, truck. And then that's the table you create for truck. And then you say, yes or no. Is it a truck? No, 0. Is it a truck? No, 0. Is it a truck? No, 0. Is it a truck? Yes, 1. So when you match that up 1 to 1, okay, that gets excluded. All right. Researchers often use this missing category as the reference group, and other categories are compared against it. Okay. And then you mentioned how in another post you did desserts. Okay. That's great. Here's what I want you to remember about dummy variables, not just how you get them, right? That's important. I want you to remember that. But the main thing is what they're for. And that is that they're used to do regression analysis with categorical data. All right. On both sides, for the dependent and independent variable. Because now think back to the regression analysis that you did on that COVID table. Okay. You had categorical variables on one side. They were set up as a category, age between this and this and this and this. And then you had continuous variables on the other, percentage for severe outcome of hospitalization, sent into the ICU, put on a ventilator, and death, with comorbidities for the various ages. So you had an age group, I don't remember, it was like 18 to 29, one comorbidity. So that group, this is a categorical variable, both of them, ages 18 to 29. So we've set it up with one comorbidity. And then there's this continuous variable out here. could have a whatever percent of ending up in the hospital. 2 comorbidities versus 0. Okay. Well, what if you want to do a regression analysis with categorical data on both sides? All right. Well, then that's what you use a dummy variable for, is to enable you to do that. Okay. So when you have data that has more than one category and you want to do regression analysis, this is what you do. Now, why do you need to know this? All right, because this is used all the time in political science. So, for example, in the video, you got this example of what would be the fuel efficiency for cars with a certain horsepower and of a certain type. Sports car, truck, minivan, sedan. Okay. All right. But what you find in political science a lot is, what is the party preference? All right. For people of a certain age with a certain party affiliation, and not just the binomial Democrat Republican. So maybe it's Democrat, Republican, Independent, Green Party. Does the Communist Party actually ever field a candidate? Yeah, I don't know. Anyway, but let's just suppose that they did. So there's 4. Okay, now you got 4 categories. How could you do a regression analysis if you wanted to just reduce that to a single bit of categorical data? Because really, that's what it is. It's nominal data. Someone's a Republican, or they're a Democrat, or they identify this, or a member of the Green Party, or a member of the Communist Party. You would create a dummy variable that you would then use to drive the regression analysis to determine what the relationship is between party affiliation, age, and candidate that they vote for, or issue, or whatever you would put in there in the dependent variable slot. Okay? Does everybody understand that? Why you need to know what a dummy variable is and what it is I want you to know. If you don't, email me. Okay, question number 2. Let's get down to some terms here. Let's bust this thing down. What is a categorical variable? Either post an example in your response or link to an example online. Okay, Richard, you went first. We'll take you first. According to Jim Frost, don't know this guy, categorical variable is a value that is based on a number of countable or distinct groups and has specific characteristics. Okay, and it may even not have specific characteristics. It's just whatever bloody group you want to think up. All right, but we usually tend to just put together groups that are driven by characteristics. Okay, the categories have no natural order. Yeah, so there's no we could list the trucks first, or we could list the minivans first, or we could list the sports cars first, and then the minivan second. Doesn't matter. Okay. Categorical variables are also qualitative or attribute variables. Again, here I want you to break these terms down. Okay. For instance, a college major is a categorical variable such as psychology, political science, and biology. And the reason I want you to break these down into simple language is because there's something that you're missing here. Okay, here's what I want you to get from this. So yes, categorical variables are, now remember, there are things that can be, data is always just swimming around out here. We can describe it and we can put it down on paper as a categorical variable, or we could put it down on paper as a continuous variable. Same data, 2 separate ways. And I'm going to give you an example in here in just a second. But categorical variables are made up of categories. Okay, and we have 2 distinct types of categories that we could put data in: nominal and ordinal. Nominal, as the name implies, nominal, it comes from the Latin word nomen, meaning name, or we have it now, name or nomination. Okay, these are categories that are represented by words. The types of cars: sports car, sedan, minivan, truck. Okay, this is a description of the thing. Ordinal, all right, these are categories that are driven by numbers. Age, what's your age? 18 to 29. 30, what was the break on that study? Let's just continue that. So 18 to 29, 29 to 38. Okay. So those aren't descriptors in the sense that it's like van or truck. They look at a number, okay, meaning age. Okay, so categorical variables are either nominal or ordinal. Okay, and there are ways, this is a way to represent data. It's not a type of data. It's how the data is represented. Okay, you might say, well, hey, Dr. Gardner, you said that already. Yeah, well, I said it again. Because here, look at number 3. What is a continuous variable? Okay, Jasmine, I like what you're doing here. Continuous variables are numerical variables with a value that is obtained by measuring. Okay. With these, measurements are usually done by scale. Okay, we set up a scale. Continuous variables are variables in between any two numbers. There is an infinite number of values. Okay, or there could be. All right, yeah. So there could be, even going past 0 down into the negative, and going out on the positive to infinity, and then we just pick a range, and then we measure within that. Okay, that's exactly right, and that's very good. But remember that continuous data, which is what comprises a continuous variable, is not data that's out there. It's how we write it down. Let me give you an example. Okay, so let's say that you wanted to record. I'm going to hold up my sheet here, okay, and I'm going to talk behind it. Let's say that you wanted to record eye color. Okay, so you could record eye color as either continuous data or as categorical data. How would you do that? Let me show you. Okay, so here's a way to record it as continuous data. You'd use something that's called a Likert scale, which is a scale, always odd number. This is usually 1 to 5. And you'd say, please respond to the following statement by selecting a number from 1 to 5. My eyes are brown. Strongly disagree, disagree, no opinion, agree, strongly agree. Well, my eyes are brown, so I would pick strongly agree, number 5. All right, now, I could have created a scale that, was from negative 20 up to positive 21, and then broken it down into degrees of selections. And this scale, as I said, is called the Likert scale because it was invented by some dude named Likert. That's the only reason. And 5 degrees of separation are usually enough to let people, make sort of a choice between things, and that's all you need. Some Likert scales can be 7, can be 9 elements long. The way the research works is if you give people too many choices, it becomes hard for them to distinguish, some degree of difference between, let's say it's 9 items long, and they're looking at, and 5 is the balance point. So it's 1, 2, 3, 4. 5 is the middle point. 6, 7, 8, 9. And they're looking at going, well, I don't know. I mean, what's the difference between the third option and the fourth option? Really can't tell. So 5 is about enough. Okay. So you could ask, please respond to the following statement. My eyes are brown, with a Likert scale. Or you could ask this, and you would create nominal categorical data. What color are your eyes? Brown, black, green, blue, hazel. So you would give them these word bracketed categories, nominal, to put their answer in. Same questions. All right. You're questioning the same thing, I should say. Eyes, different way to write down the data. Please remember the difference. All right. We do not find categorical or continuous data. We write it down as categorical or continuous. All right. All right. Number 4, look online and find an example of regression analysis with a categorical variable, post it or link it, explain what's being analyzed, et cetera, et cetera. Okay. So this one, each of you had some really interesting stuff. Rebecca, I thought what you pulled up was fascinating. You said in this study, the researchers examined several factors that affect student engagement and education. They concluded that all girls' schools had a higher level of student engagement than all boys or co-ed schools. In addition, they found that the higher the education level of parents, the less engaged the students were. I found this particularly interesting to me because we have a daughter who's planning on going to an all-girls school, and it's expensive. Ugh. So I want a high level of engagement. On the other hand, both her mother and I, we have advanced graduate degrees. So it's like, where exactly is my money going? That concerns me. Okay. In addition, they found that higher education level. Since higher engagement leads to greater academic success, further research can be conducted to understand how to increase student engagement in all students. That's an excellent example. Excellent, excellent. All right, and very interesting. So everybody click on the link and take a look at the study and the data, which it's explained pretty well and pretty straightforward. Okay. All right, everybody. That's about all our time. Again, remember the difference between categorical and continuous. Remember that data is not found as categorical and it's not found as continuous like you would find an apple and an orange. It's recorded that way, and you can record data about the very same thing, eye color, in any of those categories that you like. Now, you might be asking as we're wrapping up, okay, well, very interesting, Dr. G, but why would I want to record it as categorical as opposed to continuous? Well, the question is, what kind of tests do you want to run? If you want to run a regression analysis like we did with the COVID data, then you're going to need at least half of that data is going to have to be continuous. Or if not, if both sets of data are categorical, then you're going to have to create dummy variables if there are more than 2 categories, like say eye color. All right, so that's why you'd want to do it. That's how you do it. Okay, everybody, again, if you have any questions about this, if you're not sure, please reach out to me. Send me an email, call me during my office hour. You know that I'm thinking about you and I'm praying for you. And have a great, great week. I'll see you on Blackboard. Bye-bye.